The following source table comes from the previous section, which presented a study with two factors. Factor A was self-esteem, and you can see in the cells below with two levels, low and high. And factor B was the audience condition with two levels, no audience and audience. Each treatment condition had 15 different participants, and so we're asked to fill in the source table here, and we are given a hint to start with the degree of freedom value. So I'm going to fill in the source table starting with the degree of freedom values. I've already pre-written some information to help speed up the process. So first we start with the degree of freedom between, which is simply the number of cells minus 1. And so in the table above we can see we have 4 cells. So that's going to be 4 minus 1, which will equal 3. So degrees of freedom between treatments is 3. And then degrees of freedom within is simply the sum of the degrees of freedom for each treatment. So each treatment had 15 participants. So we could do, and we know we have 4 cells. So for cell 1 it's 14 degrees of freedom, cell 2 is 14 degrees of freedom, cell 3 is 14 degrees of freedom, and cell 4 is 14 degrees of freedom. So when we sum those up, we get 56. Another way to do that is if you know you have equal degrees of freedom in each cell, meaning you have an equal number of participants in each cell, you could also do degrees of freedom times number of cells. And so that would simply be 14 times 4, which would equal 56. And then we'll just fill that in our source table up here. Okay, and then moving on to the treatment degrees of freedom. So we'll do degrees of freedom for factor A, which is the self-esteem condition. And if you remember from the cells I showed above, there are 2 levels of self-esteem, low and high. So the levels of factor A are 2 minus 1 equals 1 degree of freedom. And so for degrees of freedom for factor B, which is audience condition, if you remember from the table above, we have 2 conditions, no audience and audience. So the number of levels for factor B is 2 minus 1 will give us 1 degree of freedom. And for the interaction, it's simply the degrees of freedom between, which was 3, minus degrees of freedom for factor A, which is 1, minus degrees of freedom for factor B, which is 1. So we have 3 minus 1 equals 1. So all of those have 1 degree of freedom each. So we can fill it in the source table as we go. So audience has 1 degree of freedom. Self-esteem has 1 degree of freedom, and the interaction has 1 degree of freedom. And all we need to do is find the total degrees of freedom, which is simply the between treatments degrees of freedom and the within treatments. So 56 plus 3 is 59. So I'll just show that to you down here. So in equation format, 56 plus 3 equals 59. There's another way to do that. So if you have a capital N, which is the total number of subjects in your study, so here we know we have 15 subjects per treatment condition, so the total number of subjects is 15 times 4. That's the number of cells or the number of treatment conditions, which is 60. So you can see here you have n minus 1 for degrees of freedom total, which is 60 minus 1, which is 59, which is what we found above when we added between and within. So we'll add that to the table up here. And then the next thing we need to do is start filling in the rest of the information with the information that we have in the source table. So I started with MS within. So MS within equals SS within divided by degrees of freedom within. And we're given in the table MS within equals 4. So we need to find the SS within. So let's fill in the information we have. So SS within, we don't know, but we know the degrees of freedom for SS within, and that's 56. And we know MS within equals 4.00. So solving for SS within gives us 4.00 times 56, which is the degrees of freedom within. And that equals 224. And we can fill that in the source table above here. 224. You can also double check 224 divided by 56 should equal 4. And I'll add 2 decimal places for the MS values, 4.00. And then the next one we can do is the interaction. So we're given the F value for the interaction, and we have the degrees of freedom. So all we need to do is find MS interaction, because we have the within treatment, the MS for within. So let's do this below. So we know the F interaction, I'm just going to write INT, interaction for short, equals MS interaction, INT, divided by the error term, which is MS within. And that equals MS interaction, and we know MS within is 4.00, so we're going to just substitute that in right now. And then we know that the F interaction is 5.50, so we just need to solve for MS interaction. And so 5.50 times 4.00, and that equals 22.00, and we'll just put that in the source table. So MS interaction is 22.00. There, and another thing we can do without calculation, since the degrees of freedom of the interaction is 1, we know MS interaction is SS divided by DF, so 22 divided by 1 is 22, so we can simply put in 22 for the sums of squares interaction. And another thing to notice here is self-esteem also has 1 degree of freedom, so the MS is SS divided by DF, so 29 divided by 1 is 29, so we can put the MS for self-esteem as 29.00. The next thing we could find is the F ratio for self-esteem. Since we have the MS for self-esteem and the MS for the error term, which is MS within, so let's just do that below. So the F ratio for self-esteem, I'll just write SE for self-esteem, equals MS for self-esteem divided by the error term, which is MS within. This equals 29.00 divided by 4.00 equals 7.25, and we can put that into the table above. So the F ratio for self-esteem is 7.25. 0.25. And then the next thing we can do is find the sums of square for audience in order to get the MS for audience and the F ratio for audience. So sums of square audience, and I'm just writing AUD for short, equals, so we know sums of square between equals all the factor A sums of squares, factor B sums of squares, and the interactions. Since we have the sums of squares for between treatments and the self-esteem condition and interaction, we can just subtract off self-esteem and interaction from the sums of squares between. So sums of squares between, which will leave us with the sums of squares for audience, minus sums of squares self-esteem, minus sums of squares interaction, equals, so we know sums of squares between is 67, minus sums of squares self-esteem is 29, minus sums of squares interaction is 22, equals 16. And we'll go above, so that's 16. And since it's 1 degree of freedom, the MS is simply 16 divided by 1. So 16.00, and we can easily derive the F ratio. So simply 16 divided by 4, and the F ratio for audience would be 4.00, but I'll write down the calculation for the visual learners here. And we have F audience equals MS audience, which is 16.00, divided by the error term, which is MS within, and that's 4.00, equals 4.00. And we almost have everything except for the SS total. So the SS total equals SS between plus SS within, and that's 67 plus 224, which equals 291. And then we'll add that to the source table. So we have total SS as 291. And now the source table is complete. We can make some statements about the F ratios here. So since all the F ratios have the same degrees of freedom, which is the numerator degree of freedom would be 1, and the denominator is 56 because the error term has 56 degrees of freedom. So our FCV has 1 degree of freedom in the numerator, 56 degrees of freedom in the denominator, and the one that we can find in the textbook that is closest to that is actually corresponding to the degrees of freedom of 1 and 55, and that is 4.02. Therefore, I'll just quickly write some symbols here. So the first F ratio for our audience effect is not significant because it's below that. And the two other F ratios, I'll just put an asterisk to represent significant at the 0.05 level. So self-esteem is significant and the interaction is significant.